All right, so I'm here to tell you about, firstly, Beeline, what Beeline is. It's the company I work for, and how we use Firebase to launch Beeline, kind of build our apps and our infrastructure from scratch in a very short space of time. Just apologies in advance. I've got a bit of a cold, so if I'm a bit sniffly down the microphone, I'm really, really sorry. I'm the CTO at Beeline. In practice, that means I was the first hire. I've since hired one more developer, so there's two of us kind of working on the app side. And we also we work with a firmware developer, so it's kind of three, kind of 2.5 developers really full-time working at Beeline. I used to work at SwiftKey. If you've heard of SwiftKey, they make a keyboard app for smartphones, and they also license the technology to the likes of Sony and Samsung and all that kind of thing. So you've probably used their technology somewhere. And I was there for about 5 years or so, and kind of saw that scale from very small to very large. I've kind of spent a bunch of time working on testing. I'm super interested in testing and continuous integration and all that kind of stuff. I've done some contract development as well, so I've done a whole bunch of different things. But more interestingly, this emoji never works. Stupid font, it's terrible. That's supposed to be a bike. So Beeline is a hardware product that makes cycling more enjoyable. And the way it does that is it's kind of like a sat nav, but it's not like your traditional driving sat nav that says turn left here and turn right there. Instead, it works more like a compass. So it just points you it just says the place you're heading is over there somewhere, and it gives you just a direction as the crow flies and the distance. And the idea is that you can kind of engage with your surroundings some more while you're cycling about, and you spend more time with your head up and kind of enjoying the whole process. So we're constantly adding more features and more interesting stuff, but that's the kind of core principle of the product. So to make this hardware product work, we have two apps. We have an iOS app and an Android app, and we build them separately. We build them in native code, and they work together. I'll take you through the kind of architecture of this stuff fairly soon. So early on, before I joined, before the company was even a thing, the two founders, they prototyped a lot. So they prototyped with Arduino. It's actually not from a technical background, so a lot of this was pretty ropey. But prototyping on this kind of thing, and then like taping it to a bike, getting people to cycle around with it and see if it works, getting app prototypes and seeing if those work, and just trying to make sure the concept kind of makes sense. And then before long, sort of partnered with a design agency in London and put together a Kickstarter campaign, which got funded in 3 days, which is pretty amazing. And then after the Kickstarter campaign, I joined not too long after that to sort of help them with the software side of stuff. So this is kind of what Beeline's like now. So here's a circuit board on the inside. There's a screen that attaches to that, battery, various bits and pieces that go inside it. Goes inside a plastic housing with sort of 4 touch-sensitive buttons, which goes into this weather-resistant silicon case. And we manufacture the whole thing. We manufacture it all in Shenzhen in China. And then we get them shipped here, and then we sell them from our website all around the world. So I guess I'm here to talk to you more about the app and how the app works and how the kind of back-end infrastructure works. So this is our app at the moment. It's pretty simple, but we're always adding more stuff to it. Its main job is to basically take the information from what you say. If you say, I want to go here via here and here, to make sure it's sending that data over to the hardware, and the hardware stays in sync. And that happens over a Bluetooth Low Energy connection, and it's kind of constantly whirring around in the background. So let's skip on through. So when I joined the company, we'd promised to ship the whole product in about 3 months' time from when I joined. At that point in time, we had a kind of iOS prototype. We could just about on Android send some data over to a Bluetooth thing, and we sort of had some hardware that was in production on the way, and we didn't really have the final stuff. And we had 3 months to basically build everything. So that included user authentication. So we want to know who users are. We want to store their data somewhere so we can get some information about how they're using it. They want to be able to keep their data, especially with a lot of the quantified self stuff these days. Everyone wants to know how far they've been. They want to share that around on social media, and they don't want to lose that information. And then we need analytics about how much they're using it, where they're using it, and who our kind of main users are. So So I spent quite a while looking at various different options of how to do this. We decided to just use Firebase Authentication. It was relatively new at the time, but actually super, super easy. I'm actually not really going to talk about this because it's really straightforward and the documentation's quite good. But yeah, we have Facebook and email authentication in our app. Firebase Authentication deals with the whole like sending emails to users, resetting passwords. It allows you to change all your email templates and stuff. It just works. It's really good. And then we were looking at data storage. So data storage in our app is, well, there's a few things. So one is you want to store the kind of favorites of where you want to go. So you might have a bunch of routes and favorites. You might have things that you've planned out that took you ages to plan out. And then you want to store the data of where you've been. And then you see these smiley faces down the left-hand side. So we're actually collecting feedback from people. So you can go and adjust those smiley faces. There's a cool little scroll bar thing, which makes the mouth go up and down, which is pretty cool. And so we're kind of gathering a bunch of data from people. And so we wondered where we should store this data. So for the first prototype, when we were sort of sending this out to the first 50-odd people saying, please try it out and see if it works, we would just, we create a JSON file, we upload it to S3. That's good enough. That does the job. But then we're kind of scaling up to thousands of users, and we're wondering how to do that. So I spent a lot of time looking at a lot of different options. So let's try and get a sense from the room. Has anyone used Realm here? Quite a lot. That's good. People are just using S3 and sending stuff up with S3 or storing stuff in S3. Not that many. Interesting. And then, so these are kind of the sort of two options that we explored, and we were using both of those. There's like a load of other options for storing stuff locally, for storing stuff remotely, for syncing it around the place. Actually, since we started this, Realm have come up with a way of storing data locally and syncing it in a nice way. I've looked at that, and I looked at early versions of it, and it was, the early versions were pretty terrible. I don't know about what it's like now. So if you have any experience of that, and I would love to hear about it, come and talk to me. But we decided to go for Firebase, and the reason we went for Firebase is because it's kind of got this offline first, local first approach, but then magically deals with all of the syncing data between your phone and your server, and then all the data is just on the server, and you don't really have to worry about it. So actually, it saved us quite a lot of work, and for us, that makes a lot of difference, right? So it's hosted, and it's fully scalable, and we don't have to worry about that. So that means I don't have to hire a DevOps team. I don't have to hire a load of people who know how to spin up S3 servers, or work out like the right buttons to press in S3 to make sure I've got something that auto scales and backs up properly and everything. Google deal with that. That's kind of their issue, right? Which is great. It's good and bad. It means it's a little bit opaque, and some things when performance is a bit terrible, then sometimes you kind of you just have to deal with it or find kind of creative ways around it. But most of the time, it's a really good thing. So as I said before, it does automatic synchronization to the server, which is really, really good. And it comes with client libraries. So that's really great as well. So there's a load of really cool like GraphQL services coming out there, like hosted GraphQL services, which are really, really cool. So you can put all your data in there. You can request as much or as little data as you want. But if you want a kind of offline capable sort of cached version of all of that data, you've got to build all that yourself at the moment. There's not really that many tools out there. And actually Firebase deals with that quite well. And there's some open source UI libraries as well. So if you want to, on Android, if you want to create recycler views or table views on iOS, these are all kind of built for you. You just point it at a kind of node in your database, and it will populate itself from that. And you'll have like nice smooth scrolling, and all that kind of stuff just works. Although we don't actually use that anymore. We've found our own way around that, which is much nicer. But anyway, I can go into that in loads of detail if you want to at some point. So what's different about Firebase database? Well, firstly, it's NoSQL. So NoSQL means that it's not relational. You're just storing stuff in a big old structure. There's no relationships between them. Any relationships you have to infer yourself. And then all the kind of security and permissions and your kind of data structure is defined in one file called rules.json. So rules.json is this thing that you say you can write to this place, you can't write to this place, and here are all the rules about how that works. It's also super real time, actually. So the first time you use it, it's kind of like magic. It is really cool. So you can change something here, and you can watch it change on the console, like kind of on the back end that they've got. You can, I can log into the app on an iPhone and on my Android phone, and I can just change stuff on one, and it will immediately change on the other one. And it is super real time. It's all done with WebSockets behind the scenes, which is really cool. And it's a reactive UI way of doing things. So basically, what that means is you just have event listeners on data, and then you bind your UI directly to that. So as soon as a new thing comes in or a thing is removed, you just have something that you just have a function that will handle that event and then update your UI, and everything just kind of magically updates itself, which is pretty cool. So the biggest thing you have to get your head around with Firebase Realtime Database is this rules file. Now, this rules file is, I mean, this is the default rules file, and basically all it says is, if you're authenticated, you're allowed to read, and if you're authenticated, you're allowed to write. And that means you can write anything anywhere, and you can read anything anywhere. And obviously, for most applications, that's probably not what you want to do. You want to add some structure to that so things work the way you expect. So I guess the next chunk of what I'm going to talk about is kind of how you might structure that. And while this might work for kind of playing about and for some little examples, if you've got stuff that you want to get out into production, you need to have some real idea about what structure and things you can have in there. So this is kind of about how we do that. So this is a typical Firebase rules.json file. This is how we store people's favorite destinations in the app. I don't expect you to read this. I basically just want you to take from this that it looks horrible, the syntax is horrible, and there are better ways. So let's move on to that. The other issue with Firebase rules is that essentially if you try and do an action that is not allowed according to Firebase rules, you get this magic permission denied error. And all that will happen is you get permission denied. It won't tell you why. It won't tell you what data you tried to write that isn't correct. It will just give you permission denied. And so you kind of need some other way of debugging that. So there is a simulator that they have online where it will kind of run through the rules you've got and try and point out the one that went wrong if you manage to copy and paste all the data that you tried and get it in there. It's kind of a pain. And I prefer better ways of doing this with some proper testing. So let me show you how we do that. So the Firebase team has this project. It's kind of in, they say it's in alpha, but loads of people use it, and it's really useful. It's a DSL, it's a language called Bolt. And Bolt is a language that is just a kind of data definition language that will then compile itself to the rules.json file. So this represents the exact rules.json file we're looking at before, but hopefully you can see it's a lot more readable. So we have destinations. So at the top, you've got the destinations and the path that they're at. So we save destinations in their own kind of folder for each user ID, and then it has its own ID. And every destination has a latitude and longitude, and then it can optionally have a name. So this says what types they are, and all of those are validated when you write. And if you get the types of those wrong, or you've got a field missing or something like that, you'll get a permission denied, and you'll know about it. So as well as data definition, you can set your security rules in your rules.json as well. So the next line underneath, you can see what that says. Basically, it says that anyone who's authenticated and their user matches the user ID of the path that they're trying to read can read them, and the same for writing as well. So they have to be the user ID that's defined in the path, and they can't read or write anything else. So by default, everything else you cannot read or write. So you can just run Bolt, and it will generate a JSON file. You can upload that to Firebase, and then it will basically adhere to all those things you wanted. You can do some more interesting stuff as well. So you can make types. So you can have types that inherit from other types. You can have optional things. You can do a bunch of quite interesting stuff with it. So here we've got a lat long type, and so we've made our destination extend a lat long, but it optionally has a name. So there's nice ways of kind of really splitting things up. What's really neat about this is actually when you're implementing stuff on the client side is you can basically copy this exact type structure in whatever language you want, and then you can just serialize your stuff from Firebase into an object with the same fields, and it looks the same on the client and on your server definition, which is great. You can add more validation rules as well. So our latitudes here, we specifically say they have to be between -90 and 90, and you can do a lot more of this kind of interesting validation type stuff. You can write functions. That's pretty cool. So here's a function. So here we made things a bit simpler by having a function called isSignedInUser, and we can pass in the user ID that came from the path. So this is a really neat way of saying, okay, only people who are signed in as this user ID can read this path or write this path. Pretty simple. And functions can obviously use other functions. And again, all that just gets compiled down to JSON. So, all right, so we've got something that can test our rules, but you know what I was saying before about actually using Firebase, well, as soon as you start sending some data there, if you get something wrong, it's just going to be like, no, that's wrong, permission's denied, or you might not know that you've written your rules properly, you might have a mistake in them, so testing them is really important. There is this library called Targaryen, which if you're a Game of Thrones fan, you might have heard of before. There's actually a whole Game of Thrones wiki. I don't know if you knew that, but there's a whole wiki dedicated just to Game of Thrones. Anyway, Targaryen's really cool. It's basically, it understands security rules. It's an open source library that understands security rules and can allows you to write tests against them, where to say basically, given this data, given this set of rules, can I read this data? Can I write this data? And it kind of tells you yes or no, and then you can write just tests with Jasmine or Chai, which are kind of Node, like JavaScript testing frameworks, basically. So here's an example of how you use it. Can anyone tell me what language this is? Anyone? There we go, CoffeeScript. Basically, you can write all this stuff in JavaScript. We've chosen to write it in CoffeeScript because you just write fewer brackets, essentially. It means that when you're writing these kind of big structures of data, kind of nested objects, they just look more like YAML than they do like loads and loads of brackets in JSON. So it just makes things a little bit easier. But other than that, it's basically just JavaScript. So Targaryen is really simple. You just say, here's my rules file. It's just a big, giant JSON structure, basically. And then here's the data that I want to sort of set in my database, and then we can just write expectations saying, if I'm not authenticated, then I can't read this path at destinations. Super simple. And then you can start writing all of your rules like that. So you can get a bit more complicated. So this says, so the user queen can read anything at the path destination/queen, but it can't be read by anyone else, so it can't be read if they're not authenticated, and it can't be read by this person with a user ID of Mayor. So you can see it's quite declarative, quite simple, but it gives you some confidence that your rules are doing the right thing. Now, this is really important. I don't know why that's blank. Yeah, you can do rules for writing stuff as well. So this is how you'd say, okay, the queen can create a new destination called Palace, and this is how we'd write that. And for us, this is super important because we basically have a test, and I recommend doing this for anyone who's using Firebase in this way, who's using Firebase Database at all. To be honest, we have a test for every single thing, every single operation that our app expects. So if you're going to read some data from a place, if you're going to write some data from a place, and all the places where there's sensitive data. So if you're storing people's email addresses, or you're storing a location, for example, or just some data that they typed in and that's supposed to be theirs, you can write some tests to say that only they have access to it and no other user has access to it. And that's really useful because it means that every time you write a new test or you want to refactor your bolt file or your rules file, and you can just go back to these tests, you can run all the tests and it'll say, yeah, it's totally fine actually. All those rules you wrote before, you're still good, so you can carry on. So we can actually refactor with confidence, and it's really good. This is how you set it up in NPM. So you basically just say, run Firebase Bolt, which generate from this rules.bolt file, that will generate a rules.json file, and then this will just run the tests using Jasmine, which is a fairly standard Node way of doing things. And then things get cooler. So basically, we got to this point, and I was like, okay, right, it kind of works, but this is really good, but how do we, we need to put some process around this. How does this work? So what we wanted to be able to do was us to be able to modify our rules, pull request those, send that to someone else, say that that person can check them over, make sure it does what they think it should do, check the tests over, make sure that makes sense, have something run the tests for us and say, yes, all the tests pass. and then when we merge it, we'll just automatically deploy it as well for us. So every time it goes into master, it just gets deployed to our server. The tests already make sure it hasn't broken anything that was running before, and it all just kind of works. So we just run all of this stuff on Travis. It's pretty standard. It's just like a node project on Travis. This is what our Travis file looks like. It's pretty simple. We just run npm install as you do with any node project. You run npm test to run the test as you do with most node projects. And then there's a Firebase command line tool, which you just run Firebase deploy, essentially. There's a couple of arguments you have to give it to tell it what to deploy and where to deploy. But that's it. And then it just magically appears. So this one we've got set up so it only happens when it's on master. So all of our pull requests, they don't get deployed, obviously. As soon as it gets merged, it gets deployed. It just works. And it's a workflow that works super well for us. Cool, so that's kind of, I mean, we're at a mobile conference, so I feel like I should talk about the app a little bit. Just talk about the backend so far. But genuinely, in terms of our backend, that's kind of the crux of it. Like, that's all we had to do. We didn't have to, like, hire a whole team of people who knew about databases. We just kind of generated JSON files and deployed them, and that was it. So on Android and iOS, it's pretty simple. You basically, there's documentation that tells you how to do this, but you can, what we have is a setup that points to 2 different Firebase projects depending on which version of the app we've got. So when we're developing locally, we can use a kind of test version of the database, and then when we release in production, we can use another version, and our deployment deploys to both, basically. And then, so I'll talk a little bit, I'll kind of go quickly through this, but again, you can mostly just look at the documentation for a lot of this stuff. So if you want to write some data, the simplest way to do it is you create a plain old Java object, or in this case, a Kotlin data class, which is basically the same thing. You have to give everything default values because you need a constructor with no arguments, otherwise Firebase will scream at you. And then you basically just say, here's a path, I want to write this bit of data to this path, and it will just happen. So when you call set value, that actually returns a task which you can listen for the value. You can listen for the response of, and then you'll know whether it was successful and whether it wasn't successful. But that's basically all you do. If you want to read some data, it looks slightly more complicated, but that's only because we have this kind of reactive UI. So what the reactive UI what this means is basically you add listeners on a reference. So again, you have a path which gives you a reference. That reference, you just add a value listener, and when the data changes, you get a new snapshot. A new snapshot will tell you the ID of the thing that changed, and gives you a bunch more information, but you can just get the value straight out, and this will just turn that value back into a destination class, which is that thing that was there. And then we've got a really simple way of reading and writing kind of Java objects really, really easily. On iOS, it's a little bit different. On iOS, you're kind of just using native arrays and objects, but you can wrap those up really easily into your own kind of nice objects and do your own marshalling. But it's still pretty straightforward. On the web, everything's just JSON, basically. It's just kind of Java data structures. You've just got dictionaries and arrays and strings and things. Cool. So that's kind of roughly how our app works. So in terms of like, how do you get data out? Like, what kind of interesting ways of getting data out other than just like reading and writing stuff? You can do queries. Queries are quite limited, and I'll cover that in a little bit later. But you can do some queries. So for example, if you have dates stored as a string, you can do kind of general string comparisons. So you can say, I just want the ones from here to here, or I just want everything that matches this, or I want everything that starts here and I only want the top 10, or you can do those kind of basic things, but you can only query on one thing at a time. So that's fairly straightforward. It works really, really well, but if you want to do more complex queries, it's NoSQL, right? NoSQL basically means there aren't any relations, so you have to create the relation yourself. So either you go and fetch all of the data and do that relation manually, or you create something that has that stores that data in a way that you can query more easily. There are some interesting tricks around that, but I'll come on to a few of those in a bit. So one of the cool things you can do, I've just been talking nonstop. Oh, by the way, I should say, last time I did this talk, I've done this talk twice. The first time everyone was like, oh, cool, this is really interesting. And the second time I did it, everyone was like, you've lost me. So because I changed some of it and some people asked for more in-depth stuff, which is why. So if I have lost you, please just raise your hand and tell me, because I'd like to know. Right, so I said before, queries are they're pretty limited, but you can do quite a lot with something called Cloud Functions. Now, Cloud Functions is a thing that Firebase released. It's still technically in beta, but it kind of works pretty well, and they're constantly working on it. But Cloud Functions just allow you to, in the same way you can add an event listener on a node in your app, you can add a kind of long-lived event listener on a Google server that will just do something when some data changes, which is pretty cool. And that can include writing more data. It can like query an API on another server. It can send a push notification. It can do whatever you like. It's pretty cool. So you have to write some code. All the examples when you're writing Cloud Functions are in JavaScript. Don't write JavaScript, write TypeScript. All of the client SDKs, all the web stuff, anything that's kind of vaguely JavaScript related to do with Firebase is written in TypeScript. If you use TypeScript as well, you get all the nice type inference and compile time checking and all that kind of stuff, and it makes your life tons easier. It makes all your tests a lot better. This is David East. Has anyone seen any of the Firebase YouTube videos? We've got a few. They're really cool, actually. Like, it's actually kind of a fun developer show that I would actually watch, and they're kind of quirky and sort of funny. Totally worth watching. David East is like the legend of the Firebase YouTube videos. I went to the Firebase conference in Berlin last year, and he wasn't there, and basically everyone was like, what? Why is he not here? I came all the way here just to meet him. Anyway, so this is how it works. So to write a function, you just have you call functions.database.ref. You tell it the path you want to listen on. You can give that parameters, which is really, really useful. So you can say, I want to listen on anything that destination /something/something, and it names those parameters, and then you can then fetch those parameters by name, which is really, really useful. And then you can tell it whatever you want to do, whatever you want. So this one, if you think about our structure, if you look at this structure, we've got destinations. For each destination, we've got a folder for all the users. And then essentially within that folder, there's like a destination for each of those users. Now, what this will do is allow us to put everything into one big folder, which means that if we just want to see what all the destinations are, for example, if you wanted to just stick them on a map or something, this is the way you might do it. So, anyone ever typed this before? No, good. I did work with a guy who actually managed to type that one. He had a PhD in machine learning. He typed that on his laptop one day when he came in, and then spent the next week trying. But he sort of cancelled it halfway through and spent the next week kind of half undoing it, and it was an absolute nightmare. Don't do that. In the same way, don't leave your Cloud Functions to do that. Right? You don't want to write some code where you've accidentally written something that is almost as bad as this or as bad as this that will just delete everything. This is something that is just not covered in any of the documentation, but I think is a really good best practice. You can basically, when you're writing Cloud Functions, you can write to and from the database. By default, when you're writing your Cloud Functions, your database has access to everything, to read and write everything, which is really bad. But basically, with this tiny little code snippet, you can just make up a user ID. In this case, I've kind of namespaced them with cloudfunction.beeline.co. So you can just make up a user ID, and then you can just say, okay, well, I'm just going to pretend to be a user with this user ID, and then you can write all of your security rules to say, well, this user ID can do this, and this user ID can't do this. So here's a simple example. So for example, we have a node called stats, and we have stats for each user, and each user should be able to see their own stats. So there's a Cloud Function that calculates the stats. So the user can see them, the Cloud Function can write them, and then it all just works. That's it. It's just in Bolt. We have a Cloud Function. We don't have to deploy anything other than just deploying the whole lot. If you are using Cloud Functions, just a few tips. Has anyone used Firebase Cloud Functions here? Of interest? Only like 3, 4. Okay, not very many. Yeah, again, I could talk about this for ages and ages because obviously I've been digging right into the depths of it, but I won't. But in case you're thinking of using it, take my advice. Basically, try and write as much of your business logic just assuming just normal data structures, not using kind of Firebase library components. Don't pass like snapshots and in kind of things like that around. Take the value of whatever thing that it's giving you and then do all of that based on that data. Because what that means is you can essentially just write normal JavaScript, normal functions that take normal data structures, and then you can write unit tests for those really, really easily. There are examples at this first URL of how to kind of mock bits of Firebase out to do some testing, and that is on the official documentation. It's really fiddly. It's such a pain. I'm in the process of writing like a open source thing that will just help with that and make that loads easier. So let me know if you're interested in that. And the other thing that's also not really mentioned in the documentation is this magic URL at the bottom. If you're using Cloud Functions, click that URL. It will take you to the Google Cloud Console error page. And basically, you can just say, send me emails if anything errors. And by default, that's turned off, which is insane. But that will then just send you an email if like anything production or even on your test servers or anything fails, if one of your Cloud Functions fails to run, and then you'll know straight away and you can do something about it. Cool. Yeah, deploying that super easy. So when you do Firebase deploy, it automatically deploys your rules.json that you have there, but it will also deploy your functions folder. So if you've got a folder called functions, which has all your Cloud Function code in it, it will deploy that as well. So all you have to do is just add that functions folder to your project, and you're away, and everything just works. So then what? Well, that's kind of it. That's all of our infrastructure. That's all of our infrastructure for our apps, for our backend, for our stats, for just, well, kind of the whole thing, right? And we've got a fully synchronized real-time everything, right? And I kind of built it all myself, which is pretty cool. So to be honest, I'm quite pleased. I mean, there obviously there've been a few issues along the way, but like we're pretty happy with how we got to. So right now we've got 9,000 users using this at the moment, and every time users are buying them, they're using our app. Our app was also available for free, so people can just kind of try it out and get an idea of how it would work. So that's kind of slowly, steadily growing. But I mean, I don't have any doubts about Firebase dealing with more and more users. It's not costing us very much money to run. The main cost is storage costs, but we're spending something like, I don't know, in euros, probably about 50 to 60 euros a month for like everything. That's like all of our hosting costs, which is amazing. And yeah, and it means we can iterate stuff pretty fast. So if we have like a hack day where we decide we want an extra feature, we can actually just go, oh, well, we need some server infrastructure for it. We just need somewhere to store the data. We can quickly create a pull request for that, make sure it works, merge it in, build it on the client side, and we're away. And it only takes like an hour. So that's kind of where we are. I could leave it there. Let me see how much time I've got. I've still got a bit of time, so I can get a bit fancier, or I can kind of stop for questions. I guess whatever makes sense. Let's stop for questions now, and then maybe I can go into some of the more in-depth bits if we run out of questions. Does that make sense? Do we have any questions? Yes.
I'm still wondering about the future of both. If you've seen the new Firestore.
Yeah. So that was inconveniently released about 2 days ago for me.
The security rule syntax is different. It's same as for storage.
Yeah.
Can you repeat the question?
Yeah, sure. So the question is Bolt, as in the security rules language, going to keep on living, given that Google have just released a thing called Cloud Firestore? So to give some context to that, Cloud Firestore is a new product that sits under the Firebase umbrella. So Firebase is essentially a suite of tools for building and shipping kind of apps and all the bits you need for an app. So the real-time database is one of those components. They've just made a new one called Cloud Firestore, and they're trying to get people to start using this new Cloud Firestore. It was only actually released 2 days ago. So it's slightly different in that it has supposedly more advanced querying capabilities, and the data model's a bit different. You kind of store documents rather than just a big giant structure of things. To be honest, I haven't looked into the new rules syntax, but I mean it can't be that long before either they or someone else updates that rule syntax for some of this. Because if you need to keep writing JSON that looks anything like that, that's not sustainable. That's not cool.
The new syntax is a little bit more concise. It looks a little bit like Bolt, but it's not as simple as Bolt, in my opinion.
Okay, so yeah.
I've been asking the Firebase guys, why aren't you pushing Bolt? But I always get this vague answer, and that's probably one of the reasons for there.
Yeah. So So one of the issues with Firebase in general is that actually they are constantly working on stuff. So one of the great things is that they're developing it, and there's loads and loads of time and effort going into making things more scalable and more stable and work super fast, and that's really good. But it also means that actually there's new things coming out, and things do change occasionally, and those do get announced. If you're really interested, then you can get into kind of Google's like early beta program, and it's worth doing that. But yeah, things do change occasionally. But I mean, still, they have their own SLA for Firebase. It will still keep running for as long as possible. And actually, they say that the Firebase Realtime Database is good for some things, and the document storage stuff is actually good for other things. I'm still yet to work out when to use one and when to use the other. But for now, we've kind of built this already, so we're going to stick with this. Very good question. Yes.
How well is Chetan modifying and piecing out the conflicts in documents?
Sorry, I didn't get that.
How well does Firebase work when it comes to fixing conflicts in files?
Okay, so the question is, how does Firebase deal with conflicts? So with the real-time database, conflicts are, basically you have a few different ways. You have two different ways of saving data. One is just the writes, which I showed you before, and all that will do is just, as soon as that write hits the server, it will just overwrite the thing. You can implement your own kind of like locking mechanism type stuff, because Firebase has like server timestamps. So you can include a server timestamp, and then you can write a rule that will kind of accept or reject a rule based on server timestamps. That's one way of doing it. The better way of doing it is there's a transaction mechanism. So a transaction in Firebase is actually quite simple. All it does is it's just a function that runs. Basically, it just says here's the old value, and then allows you to kind of update it with a new value. If before that's actually committed, something else has written it, it will just run that again, and it will give you the new value that came in, and then the old one will just be defunct. So it will just kind of run until it succeeds. It's a really simple way of doing it, but it means you can build things like counters and stuff like that really easily. Yes, at the top.
So let's say the future is mobile, so I guess having a database in the cloud makes sense. So I'm wondering, what's the arguments against Firebase? Why should I not use MySQL or Postgres? And let's say in the future I want to build a chat. So obviously the read time function is good for that. And I want to do it with cross-platform, web, iPhone, Android. Again, why should I use something else than Firebase?
Okay, so the question is, I guess, why should I not use Firebase, and what are the other options? Is that right? Yeah. Well, there are some downsides. Firstly, all your data is stored on Google servers. You don't have control over precisely where those are unless you specifically ask for it. And the distribution of those servers is something you have particularly fine-grained control of. So if latency is an issue, that could be a problem. There's things like, if you need to have ownership over that data and you need to self-host it, obviously that's not sustainable. There's if you need to run something in China, don't use Firebase, because China can't access Google. It doesn't work. So there's a number of reasons. Also, there's things like if you need to build, if you want an application that has like a bit of extra fault tolerance, essentially if you don't trust Google to build their own fault tolerance that's good enough, if you want an extra layer in between, that's actually really hard with Firebase. If you want to put like a server in between that's forwarding all requests backwards and forwards, because it's using some clever WebSockets, and actually it's not like, so the implementation on the server side is quite opaque. It's actually quite hard to do that. But for getting something kind of small and quick off the ground, so for small to medium things, I think it makes a lot of sense. For like really, really big things, I'm not too sure, right? So there's, if you want to do really complex queries, right? So if you've only got, even if you've got 1 million rows in your database, using MySQL makes loads of sense, because you can do some great queries on that. If you've got 1 million items sitting in Firebase and you want to query on those, that's quite awkward, to be honest. And what a lot of people do is they'll write things like cloud functions or just kind of batch jobs that will take that data and then just stick it somewhere else, and almost use Firebase as like a data warehouse. So you can just once a day take a dump of all your data, stick it in MySQL, then you can write queries on it, and then so you can kind of pick and choose your tools. And there are some other things coming out there. There's some really good GraphQL tools coming out. I remain to be convinced about the new Realm stuff, but I would like to see that being used. And yeah, there's a few things. There you go. I hope that answers the question. Good. Yes, Johannes.
What's the size of the database that you're using, or what's the largest database that you've used with Firebase?
I mean, I think in total we've got, I think we're like up to tens of gigabytes. We're not up to loads. So the kind of thing that I think it's very, very good for is kind of user app data. So like data that your users are generating, because you can essentially give your users just kind of little sort of subfolders essentially within your big giant data structure, and just say this is yours and this is automatically synced to your device. It's offline available as well. If you want to store like tons and tons of data, if you want to store videos, or you want to store like really detailed things, you want to store like neural network models, anything like that, don't use this. This is not the right thing. It's basically a JSON structure. It's serialized to JSON backwards and forwards. It's not the right thing to use. And especially if you have huge streams of data, if it's like very, very high frequency data, it just ends up sitting in a big giant cache and it takes ages for it to churn through. So it's great for kind of app data, for like user data that they're kind of generating periodically. You know, we're still collecting stuff. You know, we can collect stuff once a second without really worrying about storage that much though. So it's working pretty well. Got another one up there.
I have a question about pricing.
Yep.
So I understand it's free to start with.
Yep.
And then like the next category is $25.
Yes.
I wonder like how much does it take to go beyond $25?
I mean, to give you an idea, like we're at the kind of, you know, $60-ish mark at the moment, right? And what we're paying for primarily there is storage, and we're storing like I said, about, you know, tens of gigabytes of stuff. So it's not masses of stuff, but you know, it's a decent amount. But it's all sitting there in real-time database, and we can access it whenever. I mean, I would say about 98% of what we're storing is actually stuff that's just loads and loads of like big streams of data that shouldn't be in there, and we could actually just take those out and stick them as files and put them on another server, and then we can probably, you know, cut our costs by you know, a 10th or a 20th or something like that, and that'll be amazing. And we can, you know, and then we're just paying like, you know, $5 to $10 a month, and we can probably go back on that plan. The one thing that they do try and get you to upgrade for, so your functions can call out to third-party servers. Unless you're on their kind of pay-as-you-go plan, you can't do that. But I think it's worth the pay-as-you-go plan. I mean, it's you get a lot for your money. I think we're on the pay-as-you-go plan, and we were really surprised by how cheap it is. Cool. Yes.
Yeah, you mentioned, maybe it's a topic for like another talk, but you mentioned something about handling UI. I've been using Firebase quite a lot.
Uh-huh.
Like the Swift SDK, and I love it. I think it's great for like smaller to medium projects. But like handling the UI, I've used Firebase UI also. It's like tricky sometimes. Like, do you have some tips to, especially when it comes to the real-time part of it, and also I've been using persistence or offline also, and like keeping the sort of the UI in sync with what's happening in Firebase.
Yep. So the question is about Firebase UI, and specifically on iOS, and how, you know, it's quite tricky to kind of use Firebase UI to show lists of stuff that are in sync, essentially. So we've stopped using it because we just have a much simpler, more lightweight version. So what we've done is we use RX Swift and RX Java in our apps. Any RX fans here? Lots, good, excellent, like to see it. So what we've actually done is we've just built a library, and in fact we've open sourced, certainly the Android one's open sourced, I think the iOS one's probably open sourced as well, but I will check. But they're basically just, so on the Android side it's like it's an adapter, right? We call it RX adapter. On the iOS side it's basically a data source. And we just, so basically we have one file full of just like handy operators to convert Firebase events, so Firebase data value changed events to like a list of observables, or streams of lists of observables or whatever. So essentially you're just getting data as observables. But because if you're using RX, then you can kind of make lots and lots of stuff around in RX. So we've created, like on the Android side, we have an adapter that you just give it a list of observable. You could give it an observable which of lists, if that makes sense. So you just have an observable of your data, and whenever that data changes, it handles the whole updating stuff, and it's really easy to then plug in other stuff. So you can put in static things, you can put in, you can put things in the middle, you can put things wherever you want by just using the RX operators to take that data and then just combine them using, maps and filters and joins and all that kind of stuff. And it works really neatly, actually. Cool. One more up there. Yes.
To understand, you do
Yeah.
native development in both. So how would, like, if you compare with React Native, how would you?
So the question's about React Native. So you're correct, we do everything in native. You can use this in React Native. There are actually two different ways to use Firebase with React Native. One is you can just use the JavaScript SDK, which sounds a bit mad, but you can do that. So you can just use the JavaScript library and you can just run that in React Native and it works. The problem with that is it's designed to work in a browser environment which is single-threaded, and so actually there's like loads of bottlenecks and it's kind of slow. There's an open source library that actually wraps both native Firebase libraries. So you can use essentially the same API, but under the hood, it's using the native ones to kind of do all the background fetching and queuing and all that kind of stuff. And it all just, it does hang together reasonably well. We did do some experiments into using React Native for our stuff, but we just found for our app, there's too many native specific things that we need to do. So we actually stayed away from it in the end. Yes.
Yes. So we are running out of time. Thank you, Chetan. Excellent talk.
Thanks.